देख जरा आई अब इसी यूट्यूब से उसके की थी मेरे को जरा 1 मिनट अभी जा रही है आपको उसका यूट्यूब लिंक
यहाँ से आ जाएगा।
2 मिनट
आ गया
ना। अब इसको सर को देते लिंक इसका, ये उठा यूट्यूब कहाँ रखा था
यूट्यूब। अच्छा ऐप सर नहीं ऐसे ही खोल दिया था यहीं पे।
तो इस पे नहीं खुलेगा, इसी पर रुकिए।
अच्छा ये वाला इसका
बस वो है ना, टॉप है टॉप
ये वाला।
हाँ कॉपी कर दो। नहीं सर ये है शेयर लिंक करो यहाँ से, बस आप व्हाट्सएप पे करो शेयर अपना, ये यहाँ की बात है, यही लिंक आएगा।
सेम ही है वहाँ से भी कॉपी
व्हाट्सएप को ओपन करना पड़ेगा ना, ये डायरेक्टली आ जाएगा। इसका खुला है राकेश जी का, संजय सर को भेजो, संजय सर को उसको भेज दिया ना गुंजन को, आप नीचे बैनर वाले को भेज दिया कहीं भी जहाँ तुम्हारे को प्रॉपर गूगल मीट भी चलेगा।
गूगल मीट साइड बाय साइड।
हाँ चलिए इस पर गूगल मीट लॉगिन है।
अच्छा यहाँ से चल पड़ेगा सर, लेकिन दोनों चीज़ें एक साथ
वहाँ पर
होती नहीं है।
कोई नहीं। अभी आप जाओ गूगल मीट यहाँ से ये खुला हुआ है। नीचे में बच्चों को बोलना है सर, संजय सर
हेलो 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 हेलो
ऑन किया आपने?
यूआईटी जा रहा है ना? हाँ मैं भी आ रहा हूँ साहब। हेलो 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 to the online attendees, am I audible to you? You can just text us or unmute yourself and say, am I audible to you? YouTube पे मिस नीलम हेमंत, मिस प्रियंका, मोहम्मद अबीदीन बेकर, am I audible? शुरू कर रहे हैं हम लोग।
ये तो टाइम लिखा हुआ है।
मैंने अनाउंस भी किया था कि प्रीपोन कर दी है, तो अनिंदा सर की होगी ना, दोनों में से किसी एक की तो होगी।
ठीक है, हाँ एक तो होगी।
दिमाग इतना तो लगा नहीं है यार।
हाँ लंच के बाद, हाँ वो तो मेरे को पता है, लंच के बाद अब एक ही बचती है, वो तो मैंने देख लिया। लंच के बाद एक ही बचती है, वो बोल रहा हूँ कि 2:30 बजे ना।
इस वक्त धोखा किसी की भी है।
ठीक है, फिर उसके बाद फिर वो नीचे वाला जल्दी करना है, 3:40।
हेलो हेलो am I audible? Please join us fast because I am going to announce a wonderful news from Stranger Nature, and that is for the authors who will be presenting their paper in physical mode. ओपी ये अनम्यूट कर दो मोहम्मद अबीदीन बेकर को।
जो PDF यहाँ पर ओपन होगी
चलेगी फिर भी चलेगी
शेयर कर दिया।
चलेगी चल रही है भाई लगा दे
अगर चार्ज हो जाए तो दे दो। चार्ज हो रहा है भाई ये तो आप बता दो।
हिमांशु हिमांशु
चलेगा या वहाँ कैसे प्रोफाइल बने
हिमांशु से आगे ले सकते हैं क्या स्क्रीन को? आगे ले सकते हैं स्क्रीन को या गड़बड़ हो जाएगा? स्क्रीन को आगे ले सकते हैं, गड़बड़ हो जाएगा।
दे दो ओके दे दो उठा दो दे दो
कंटिन्यू करना पड़ेगा।
चलो तब तक स्टार्ट करो प्लीज टेक इट
क्या पॉइंट लगा देते बॉक्स पहुंच जाएगी मेरी वाली।
हाँ मैं ये रिक्वेस्ट कर मैं रिक्वेस्ट द पार्टिसिपेंट्स टू कम फॉरवर्ड प्लीज। मैं रिक्वेस्ट बिकॉज वन ऑफ द स्पीकर वी मस्ट शो सम रेस्पेक्ट टू द स्पीकर प्लीज कम फॉरवर्ड यू नो।
ये जी ना बॉक्स ले ले पर लगा देना पर लगा देना इसको ज्यादा बेस्ट बेस्ट मिलेगा वहां रेंज पकड़ेगा
यहीं से नहीं हाँ ये शेयर करके रखा है। हाँ ये यही की स्क्रीन जाएगी, आप देखेंगे यहाँ से वो कैमरे से वो जो कैमरा लगा है ना सामने वाला वो कैमरा। ये एक बार बंसल सर दिखाई देंगे ना उससे? आप कैप्चर करेंगे ना? एक बार ज्वाइन करके दिखाओ फटाफट।
कैमरा वहाँ पे फोकस है
वो उन्होंने सही करके रखा है वो
उस कैमरे को लगा दो
बस। करने में परेशानी आएगी ना जुगाड़ इनका हमारे यहाँ कब लेते हैं आप ऐसा लगा रखा है। अब आपकी बिल्डिंग बन जाएगी तो दूसरी वाली को पानी फ्रेश है एकदम। हाँ देखिए सर ये आया हम लोग वो अगर आप कोई देखा होगा ये हमारे लोग को जोन देखोगे मेरे लोग मेरे फोटो अपना लोग बनाते हैं वहाँ शाम को देखोगे फोटो कॉन्टेक्ट। सर की पहले वाली स्क्रीन जो है जो शेयर करके रखी हो दे दो। वेरी गुड आफ्टरनून।
व्यू पे जाके या कंट्रोल एल कर दीजिए, कंट्रोल एल कर दीजिए। ये तो पढ़ लिया था पहले
मैं घर में बात तो बोली थी ब्रेक तो लाइन ए वेरी गुड आफ्टरनून। अब चल नहीं रहा है।
जैसे था सर आज तो
टाइल मिक्स आ जाएगा ना।
नहीं 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 ये नहीं सर, ये इसमें लगाना है।
अच्छा
मेन लाइट ये है। मेरे को पता, सब पता था, तो लगा दूँगा।
क्या स्विच क्या स्विच करा
कॉलर माइक लगा ना लगाना,
कॉल क्यों मैंने मना किया था ना
तब तक नहीं एक्सटेंशन होगा।
हेलो हाँ?
आवाज़
आपको लगता है कि मैं टच में नहीं हूँ? टच पे कहाँ हूँ? मेरे पास टीचर डे का, हेलो हेलो, टीचर डे का और नए साल का दो में, वो टीचर डे का उनके बर्थडे का दो ही भेजते हूँ मैसेज। ऑन है।
हाँ अब चल गया ना। चल
ट्रायल तो नहीं कर रहे? A very good afternoon and welcome to the next session of the 3-day international conference. This session was scheduled for the talk of Mr. Aninda Bose, but because of certain health issues, right now, Professor Jagdish Chandra Bansal, Associate Professor in South Asian University, New Delhi, will take and deliver the first keynote talk of this 3-day international conference. Before inviting him, it would be my proud privilege to say few lines about him. Though he hardly requires any introduction, Dr. Bansal is an associate professor at South Asian University, New Delhi, and visiting faculty at Maths and Computer Science, Liverpool University, UK. Dr. Bansal has obtained his PhD in mathematics from IIT Roorkee. Before joining South Asian University, New Delhi, he has worked as an assistant professor at ABV, Indian Institute of Information Technology and Management, Gwalior, and BITS Pilani. His primary areas of research is swarm intelligence and nature-inspired algorithm. Recently, he proposed a fusion social system-based optimization algorithm, a spider monkey optimization algorithm, which is being applied to various problems from engineering domain. He has published more than 100 research papers in various international journal conferences. He is the editor-in-chief of the journal Method X published by Elsevier. He is a series editor of the book series Algorithm for Intelligent Systems and Studies in Autonomic, Data-Driven and Industrial Computing published by Springer. He is the editor-in-chief of International Journal of Swarm Intelligence published by InterScience. He is also the associate editor of Engineering Applications of Artificial Intelligence and Array published by Elsevier. He is the General Secretary of Soft Computing Research Society. He has also received gold medal at UG and PG level. With this brief introduction, I would like to invite Dr. Jagdish Chandra Bansal to deliver first keynote talk of this conference. Sir, please.
Good afternoon, everybody, and thank you, Dr. Tarun, and the other organizers, Dr. Sanjay, Dr. O.P. Verma, for this opportunity to speak here. The title of the talk is Drone Swarm. Usually, the swarm word comes with the intelligence, and this intelligence, when is applied to the drones, is known as the drone swarm. This is one of the most recent research area in the field of soft computing. The drone swarm, the algorithms customized for drones, a group of drones, for the group of drones. Till now, most of the soft computing algorithms are either for the data handling or for the optimization purpose, or to make the machines intelligent. This is the first time when the machines are becoming the drones. To make the drones intelligent, can we develop certain kind of soft computing algorithms? So So this is the attempt, the drone swarm is an attempt to make the group of drones intelligent. Now, since this is the very recent area of research, in last 5 years, particularly in last 4-5 years, people have started taking this name drone swarm. Otherwise, usually the people used to call it drone or the swarm intelligence. The drone swarm concept came in last 4-5 years and is becoming very popular. There are certain misconceptions about the word drone swarm. Any group of drones is not a swarm. There are certain conditions, there are certain requirements, those are to be fulfilled. Only then we can call a group of drones a swarm of drone. So any group of drones cannot be called as a swarm of drones. So these are just my quick recap of quick list of the topics which I'm going to cover in the drone swarm. First of all, why the drone swarm? What is the drone swarm? What are the challenges in the research in the drone swarm? In the drone swarm, how the one drone moves from one point to another point, that is the position update in communication, how they communicate with each other, what are the possible application areas of the drone swarm, and what kind of drone swarms are available, what is the future of the drone swarm, and at last, if the time will permit, my recent research on the drone swarm I will share. So actually the drone swarm or the DS, I may call it DS for the drone swarm. It is important because of its various applications, not only into military but to the civilian areas also. The swarm intelligence is important because, let me give you an example. Imagine a situation, right? So actually to understand the importance of any topic is through a situation. So think of a situation where there is a farmer and he has a farmland. He has to spray the pesticides. He has to spray the pesticides the one way that the traditional agriculture techniques do, that is done manually. Then he bought a drone. So through drone, he is spraying the pesticides. One drone, he is spraying the pesticide. Just imagine a situation that to cover the entire farmland of the farmer takes, suppose, 10 hours. One drone is taking 10 hours in spraying the pesticide. Now, if he bought 10 drones, instead of one drone, he bought 10 drones and applies the swarm intelligence He bought the 10 drones instead of one drone and applies the swarm intelligence among those 10 drones. Then can anybody tell me how much time he will take to spray the pesticides in the field? The one drone can spray the pesticides in 10 hours. Then 10 hours equipped with the swarm intelligence. How much time it should take? 1 hour, right? So there's a usual answer, but it is not with the swarm intelligence. The correct answer is less than 1 hour. Of course, mathematically you said it correct, that it should take 1 hour. When the one drone can solve a problem in 10 hours, then 10 drone will solve in 1 hour. But I told you that the swarm intelligence is there. Some intelligence emerges when the 10 drones are working together. So the total time taken to spray the pesticides in the field will be less than 1 hour. To make it possible that 10 drones can spray the pesticide in the field in less than 1 hour, we have the algorithms, swarm intelligence algorithm. So this swarm intelligence is important. It is not an ordinary serial application of if the 10 drones are solving the problem or are spraying the pesticide in 1 hour, then it is a group of drones. It is not a swarm of drones. If they are solving the problem in less than 1 hour, then it is a swarm of drones. Means some intelligence is there. When the intelligence is there due to the group behavior, only then we call it a swarm intelligence or the swarm drone. Okay. So the swarm intelligence, I think no need to explain if you have studied the soft computing or you have some exposure of the soft computing. Swarm intelligence is one of the key significant area, and actually, in fact, in 60s, the swarm intelligence based algorithm or the population based algorithms people have started using, but they become, with the name swarm intelligence, they become popular in 90s. In 1992, first time when the Marco Dorigo, one Italian scientist, proposed one very popular ant colony optimization algorithm, which is based on the foraging behavior of ants. When in 1992 he proposed, at that time, first time people realized that, okay, this is somehow different than other population-based algorithms like genetic algorithm, genetic programming, evolutionary strategy, evolutionary programming. From those kind of category algorithms, this kind of algorithms are slightly different. And therefore, the people started to consider them as a separate class of algorithms, the swarm intelligence-based algorithm. And then, just after 3 years, in 1995, another algorithm proposed particle swarm optimization by 2 US scientists, James Kennedy and Russell Everhart. After again 3 years, in 1998, another algorithm, artificial bee colony algorithm, was proposed by Karaboga, by one scientist, Karaboga. So, with the invention of these three algorithms, the swarm intelligence area was established completely, and people started to take the nature-inspired algorithm in two categories: evolutionary and the swarm intelligence. Earlier, they used to call them the evolutionary algorithms only. So the swarm intelligence, of course, is in demand because it is solving the problem in a better way, in more efficient way, in more accurate way as compared to the earlier existing population-based algorithms. And therefore, the swarm intelligence is important. I already told you that the drone swarm is important with that example of, always remember that example of farmer who is using 10 drones instead of 1 drone, and he want to make the time less than 1 hour. And if he want to make the time less than an hour, he need the swarm intelligence based algorithm. Means he don't need the group of drones, he need the drone swarm of drones. And therefore, the drone group is different than the drone swarm. And for drone swarm, of course, we are in need of the swarm intelligence based algorithm. But let me tell you, the algorithms developed by Marco Dorigo, Russell Everhart, or the Karaboga are not directly applicable in case of the drones. They are not applicable directly. They have designed these algorithms especially for the optimization purpose. We need to customize them for the case of the drone swarm. In case of the drone swarm, we have to customize them. Now, how to customize them actually differs situation to situation. If you are developing a drone swarm for the farmer, if you are developing a drone swarm for the military person, if you are developing a drone swarm for the delivery, if you are developing a drone swarm for the transportation case, every time you have to customize the algorithm according to the situation. Okay, actually I have a video here. I could not upload it here. So this is the formal definition. Actually, when 3.5 years before I started working in this area, I could not find a proper definition of the drone swarm, that which kind of group we should call the drone swarm. So at that time I defined this formally. So this is the formal definition. 3 years before I gave this definition, it is called an interacting autonomous group. First of all, in the group of drones, all the drones should be interacting with each other. They should not be separate parties. 10 drones flying independently with no communication with each other, it's not a drone swarm. So first of all, they should be interacting. It is an interacting. Another property is the autonomous. Autonomous means there must not be any control. There must not be any RC, remote control. There must not be any remote control at the operator who is operating the drones at the ground station, or they should not be controlled by the GCS. They should be autonomous system, means the system itself should understand that how to communicate with each other, at what speed need to fly, at what altitude need to fly, how to solve the problem, in which direction need to fly, the speed of the flight, distance between the two drones, maximum distance between the two drones, every parameter is to be decided by the drones itself during the flight. So it should be a complete autonomous system. Only in that case you can imagine some kind of intelligence can emerge. If it is controlled by the GCS, intelligence cannot be guaranteed. Intelligence can be expected only if the system is autonomous. So the first property is interacting, autonomous, and of course it is a group. Group means how many drones? Can you think of a drone swarm with 2 drones, 3 drones? No, actually no. It is also a group. It is also a group, 3 drone, 4 drone, they are also a group. But let me tell you, I did some mathematical analysis. I did some mathematical calculations using the stability analysis of the solutions through matrix analysis. And I realized that the minimum swarm size to have the intelligence is 12, is actually 12. So the minimum 12 number of drones are required to have the intelligence to emerge, right? But practically when I solved the same problem through simulation, so the simulation was giving the minimum result 10, right? So 10 is giving the simulation, and theoretically I was getting 12. I wrote a blog also on this. So actually 10 to 12, these are the approximate algorithms. You know that soft computing, during the inauguration I mentioned that it is no rule, all these soft computing algorithms has no rule except one rule. There is only one rule, that there should not be any rule. Means there should not be any deterministic decision. Whatever the decision you are taking, whatever the step you are taking in soft computing algorithms, there must not be any deterministic decision. All the decisions must be probabilistic decision, means random component based decision. So I always say that the soft computing algorithms has no rule except one, that there should not be any rule. If there is a rule, it means you are deviating from the basic principle of the soft computing, that is the stochastic property, stochastic decisions, probabilistic decisions, right? And therefore, the my theoretical outcome of the minimum swarm size, that is 12, and the simulation outcome, that is 10, is actually matching. So 10 to 12, whatever is the minimum swarm size will work, and you can expect some intelligence from the drone swarm. And if, of course, more the swarm size, better the results. But there is always a threshold that after certain size, the improvement will not be there. There may be a problem, right? So, and that what is the maximum swarm size cannot be mentioned, cannot be derived mathematically or through simulation, because it always depends upon the problem. What problem you are doing, what is the size of the search area, what is the region of interest, what is the size of the region of interest, or the maximum swarm size depends upon that. So there is no bound on the maximum swarm size, all depends upon the problem. So it is an interacting autonomous group of drones, and the last property is that it should be assigned to perform or some task, one task or some other task. Means they should be able to do some work. For example, efficiently they are able to solve the problem of farmer spraying of the pesticides, right? Or identification of the faulty leaves. You know, the classification, they through image processing, they in the real time they can do the classification and can classify the faulty leaves, and accordingly another set of drone swarm can go based on the input of the first drone swarm, who is identifying only the faulty leaves, and can spray only the faulty leaves, only the faulty plants, not all. Because even if you are doing it manually, you need to do it every plant, but this can be done very quickly. And actually there was a research paper published by a Taiwan researcher. I don't remember the exact title of that, but they said that around 10%, only the 10%, as compared to the manual spray, only the 10% pesticides are required if you use the drone swarm for the pesticide spray in the farms. Just imagine this situation, that how much extra pesticides are being sprayed by the human being. So the drone swarm are always important, swarm intelligence are always important. These are the objectives of the drone swarm are actually what we are going to do with the drone swarm. So this is in the drone swarm, we do a research, we develop an algorithm in such a way that a group of 30 or more, why I wrote 30 or more, I said that if 10 or 12 will work, means you can emerge, you can expect some intelligence, but that intelligence may not be sufficient. So the sufficient intelligence can be expected from the 30 or more. So usually 30 or more drones group is there, then you can believe on that system that they will be able to solve the problem completely. Connections among them, the most important challenge in the drone swarm, that how they are connected with each other. I'll tell you in my subsequent slides, I will tell you that what is the major challenge with respect to the connections. The ability to perform a well-defined task, and all this depends upon the problem domain. If you are developing a military domain, the ability differs. If you are developing for the farms, if you are developing a transport drones, the abilities differs, right? So that depends upon the problem domain. So I actually explained whatever I said already. Just the drone members should be able to communicate and collaborate autonomously, preferably without any central control. Actually, what happens, this area, drone swarm, became popular in just 4 or 5 years before, and therefore the technology is much not matured. Technology in this area is yet to be matured, and therefore the complete autonomous system is not available till now. A fully autonomous system, drone swarm system, is not available, and therefore I mentioned it preferably. It is preferred that there should not be any central control, but still there are certain controls are there. Certain controls are on the GCS. The swarm should be an independent or autonomous system which can find out the target in complex landscapes. Means a small plant is there, and just nearby a large plant is there. So they should be able to distinguish. They should be able to find out that a small plant also, if it is faulty, they should be able to, if it is a survivor drone swarm, survivor identification drone swarm system. Suppose there is an avalanche. You people can understand better, those who are in Himachal. Suppose there is an avalanche and some tourists stuck out in somewhere, right? So to find out those, so landscapes are of course very complex. So they should be able to work in those complex landscapes also. Classification of drone swarm based on the autonomy. Based on the autonomy of the swarm, the classification is done of the drone swarm system. Based on the communication, the drone swarm is classification is done. So there are two ways of classification of the drone swarm. One is based on the autonomy. So it is fully autonomous or semi-autonomous. Fully autonomous, I already told you, all the decisions after takeoff, no control at the GCS. GCS is just an observer. GCS is just an observer, no control at all. So that is called the fully autonomous system. But the system is yet to be matured. A lot of sensors research is being done. Lot of GPS issues are there. GPS is not 100% accurate. GPS problem is there. And of course, the engine problem are there. Communication problem, most important problem is the communication, not the intra-drone communication. Drone and the GCS communication. So if you are sending your drone swarm system 100 kilometers far from the GCS, of course the communication may lose because the target may not be at the line of sight. Usually, right now, what the foolproof system available, what the robust system available is on the line of sight. If the system is at the line of sight, it is quite robust system, and there is no issue with the communication. But as soon as the system goes, as soon as the drone swarm goes out of the sight, usually the communication issues comes. So because of all these issues, semi-autonomous system is there. In the semi-autonomous system, there are certain controls which are in the control of the GCS, where you can guide the swarm, that okay, don't take this decision, there is a problem in this direction, you go in this direction. So as per requirement, the inputs are coming during the live flight from the GCS. So that is called the semi-autonomous system. Semi-autonomous system is quite working good right now. but there are certain drawbacks of the semi-autonomous system, that you always need an operator. You always, the system, success of the mission always depends upon the wisdom of that particular operator. The operator may not be aware of the 360-degree situation of the current location where the swarm is flying, and in that case, lot of dependency is on the computer operator, is on the operator, GCS operator, and therefore the fully autonomous system is the ultimate requirement for which the science, the technologists, the scientists are working, and the rate in which the research is increasing in this drone swarm, the rate by which the scientists are working so interestingly in this area, I don't think that it will take not more than 10 years then that we will have a fully autonomous system. In next 10 years, we can expect a fully autonomous system when there may not be any fighter pilot job. You may not see, after 10 years, you may not see any opening of the fighter pilot job. All these things should be maybe done with the unmanned vehicles. Of course, drones. And the size of the drones are keeping on increasing and increasing. Okay, another classification is the single layered and the multi-layered. Single layered and multi-layered, actually what happens, in the swarm intelligence also, in the traditional swarm intelligence based algorithms also, the communication topology is a great challenge. Actually what happens, if the drones are communicated, if all the nodes, all the drones are connected with each other, means suppose 5 drones are there, so it is connected with all 4, and everybody else connected with it is called fully connected structure. I think everybody understands this, fully connected structure. So it is a very good structure and robust structure. Means if one drone crashes, it will not impact the entire swarm. The remaining 4 will keep on working. But what happens, this is the robust system. But the problem with this fully connected structure is the calculation. Onboard calculation will be too much. Suppose you have 30 drones in the system. So this particular one node is getting 29 inputs from other drones, and he has his own input also from the environment. So lot of calculation is to be done on board, and accordingly whatever is the decision, the next step is to be taken. And this lot of calculation may take time. And the entire system is flying at certain speed, and if this delay is there, then there may be a collision. So the fully connected structure is never recommended when you are solving a problem in real time. And drone flying is a real-time system. It's a real-time flying system. So it is not recommended. The fully connected structure, however is robust, is not recommended for the practical purposes. And in that case, other kind of topologies are there. One topology is this multi-layered system. Then I'll tell you the single layered system. In the multi-layered system, what happens? Suppose these 4 drones are there. They are connected with this one mother drone. Another 4 drones are connected with one mother drone, and these 2 mother drones are connected another with another mother. And this mother drone is connected with the GCS. So the live feed is coming from only the one single mother drone. These are not connected with the GCS, and they are also, these 4 and these 4 are also not connected with each other, right? They are separate subswarm, so they are not connected with each other. This is making the system very fast, because they have to calculate only the 4, or these 4 are also not connected with each other. They are connected via this mother drone. So they are sending only the information to the mother drone, and mother drone has only the 4 inputs, and he has to send this information to only the one, right? So the information processing is very fast. But the problem, again, there is another problem with this system, is the safety, is the robustness. Just imagine the top mother drone falls. It is suit. Suppose you are working with a military drone system. Suppose the top mother drone crashes, then the entire swarm will be collapsed. The reliability of this system is the minimum. Reliability is minimum of this system. So this system is also again not recommended. And in that case, there is another system that is called the single layered system, which is highly recommended system. Now for this single layered system, again there are hundreds type of topology, communication topologies are there. That how single layered means all are in the same layer, all are in the same layer. There is no mother drone. All are homogeneous, which is the basic requirement also. This is the necessary condition of the swarm intelligence also. Those who studied swarm intelligence, they know that necessary condition. So homogeneity is the necessary condition of the swarm intelligence, that all the members in the swarm must be homogeneous, must be of the same configuration. Right, so single layered means all the drones are of the same configuration, all the machines are of the same configuration. In that case, they are not communicating with any mother drone, but they are communicating with each other. Now how they communicate with each other is an issue. I already told you that if all are communicating with each other, fully connected structure, robustness is, you have achieved the robustness, but you lost the speed. You lost the efficiency. So less connected structures are proposed. Let me check if I have proposed few. Yeah, here I have mentioned certain communication strategies. It may not be seen. So 3-4 communication strategies I proposed, which are actually less connected structure, and they are very simple. The idea is very simple, that instead of everybody is connected, or it is called ring topology. That is called the star topology. This is called the ring topology or the von Neumann topology. We are very established mathematical topological structures established. Just we need to use them to the drone swarm system. So ring topology means this is communicating with this is communicating with this is communicating with this, right, and so on. But in this ring topology, the problem is, if this is drawn, then this swarm and this swarm is disconnected. Means instead of one swarm, now you have two sub-swarms, and this part is disconnected. And therefore, to make it more robust, instead of connecting with only one nearest neighbor, you are communicating with the two, right? So it is communicating with these two, and this is communicating with these two and this side too, right? So even if the one drone crashes, the communication will be intact. So it is not the minimum connected structure and not the maximum connected structure. Somewhere in between, the optimized connected structure, and this you can optimize or customize according to your requirement, right? So I have proposed few here. Unfortunately, it may not be seen there from there. Okay. So there is next is the update in the drone swarm. How to update the position? How the drones update from one location to another location. That is, so the very simple mathematical equation for this will be x equal to x plus h. Means this is x is the current position, current location, and this x is a 4 tuple. This x is a 4 tuple. 4 tuple means x, y, z, t. Right? 4 dimensions are there. X, Y, Z and T for the time, at what time you are flying at that particular place, right? So time is very important. That so this X is a vector, 4 tuple vector. It's a 4 tuple vector. So X equal to X plus H. H is the information, set of informations. For example, the wind speed, temperature, altitude, the positions of the other or the target or the input from the GCS, if it is not to the fully autonomous system, whatever the information he want to share, that or he want to get from other, is the H, right? So this H all is the information. So from where, now the question is, from where I have to take this information, right? Even if so many members are there in the drone swarm, from where this information is to be taken? So my answer, actually, it is not the only answer. It is not the only answer, and it is not the not guaranteed to be the best possible answer. But I propose this one solution, that this H may be the influence from the best. Whoever is, means he is taking the information from all its neighboring members. If it is ring topology or the less connected structure, then from the neighboring members it is taking the information, and out of which whoever is the best is the G. Sorry. is the G, xg is the G. Whoever is the best is the G, and xg minus x is a vector. It is actually a vector. It is simple xxg vector. X towards xg, right? AB vector. How we write AB vector? OB minus OA, right? OB minus OA. So similarly, xg minus x is xxg vector, right? Now this T is the weight to this information. Any solution, if one particular node wants to update its position and it is taking the information from others, whatever is the information is coming in the soft computing, it is told that no rule. I told you no rule means whatever the information is coming, not to be followed blindly. Not to be followed blindly means I am giving some weight to that, and this weight is a probabilistic weight. So this T is a probabilistic weight, that how much weight I am giving to him and how much weight I have to myself, right? So this T is the weight, that is particularly the probabilistic weight. Okay, so that is the update situations. Now there are certain challenges that I have mentioned already. The topology used for communication among the drones, I already told you, but let me tell you, the lot of solutions are available, and no single solution, no single topology is applicable to all kind of scenarios, right? If you have, I already told you that military or the surveillance drones or the survivor drones or the transport drones or the agriculture drones, the communication topology differs. The optimal communication topology may be different. Another challenge is what if you are solving a problem. Particular problem is given to you that, okay, 1 by 1 kilometer area is given to you to find out the General Rawat's helicopter black box. Remember that situation? In 2 days you got the black box. General Rawat's helicopter crashed, and in 2 days you got the black box. So suppose 10 by 10, let us assume 10 by 10 kilometer area is given to them to find out the black box. That is the searcher drones, right? Searcher drones. Actually, this searcher drone is a different terminology. It's a different RPA. It is called RPA. And those who understand this, searcher drone is a different one who flies at the 5 kilometers height. I'm talking about the drone swarm, but these are the searcher drone swarm, right? So these searcher drone swarms are given 10 by 10 kilometer area, and the black box size is given. Certain size is given, that the target of this size, this is the shape of that, this is the color of that. Now for this particular problem, how many drones are required? So I said that minimum is 10, 30 is quite good, but for this particular problem, what should be the minimum number of drones? This is a challenge, right? Now every time you have to customize, every time you have to simulate the situation on the computer first, only then you can assign the number of drones to that particular problem. So this is another challenge that to decide the minimum number of drones to solve the particular given problem. Okay, maximum and minimum distance. Actually what happens, if the distance between the two drones is too close, it is very good for the intra-drone communication. They can communicate very fast with no lag in the communication, right? But simultaneously, the problem of collision increases. The chances of collision increases. They are flying. Usually, they fly at the 14 meter per second or 15 meter per second. Usually the drone swarm flies at this speed, 14 to 15. Recently, we have achieved. I'm working with a military. Drone swarm project, they achieved their minimum target is their target was, they said that our target is 30 meter per second. Of course, we achieved 26 meter per second for that particular project. So, but usually it is 14 to 15 meter per second they are flying. Just imagine, to 14 to 15 meter per second they are flying. The GPS accuracy is 10 meters. 10 meters is the GPS accuracy, and the 14-15 meter per second they are flying. Even the half second delay in the communication, they can collide with each other, right? So you cannot keep the drones very close to each other. Now the question, another immediate answer is, okay, then keep them 20 meters apart from each other. Then suppose 30 drones are there. 30 drones are there, and 20 meter, 20 meter, 20 meters. Just imagine the diameter of the drone swarm. The first drone and the last drone, communication may be lost. This is called the aggregation. Aggregation may not be too much, right? The first drone, the last drone. This is the diameter of the drone swarm should not be too much. Otherwise, this communication will be lost. Of course, you have increased the safety collision. You have avoided the collision, but simultaneously you have increased the chances of the loss of communication. And therefore, then another challenge is what should be the minimum distance, that is called the dispersion, and what should be the maximum distance between any two drones, means the diameter, first drone and the last drone. What should be the aggregation and what should be the dispersion, another challenge. And again, this depends upon your speed of the swarm, that what speed you want to keep. If you have a speed very slow speed, or some situation where speed doesn't matter, for example, the spray of the pesticides, some domestic huge drones are there. In that case, of course, you can keep the distance quite minimum, but where the speed matters, then you have to keep the drones distance between any two drones, the distance relatively high. So self-healing is another case, that if suppose you have sent 30 drones to accomplish a mission, particular suppose 1 by 1 kilometer area is to be destroyed. Just imagine a situation of the military defense case, right? This 1 by 1 kilometer area is to be destroyed completely, and 30 drones you have sent, and you set in your program, you said that okay, these 30 drones will divide their task in such a way they will divide their task. Now just imagine, in between, in the transit, the enemy has killed your 2 drones. Now you have only 28 drones. Those reached at the region of interest, ROI. They reached at that particular place. Now how to reassign the job among these 28 drones so that the entire work can be done? Means now the 1 by 1 kilometer area is to be destroyed by only the 28 drones. Right? Self-healing. This is called self-healing. Means the system should be so autonomous that they can decide that, okay, now we are only 28, so we have to do this work, to do the same work with the 28 hands only. Right? So this is the self-healing. All these are the challenges in the algorithm itself, which we need to incorporate in the algorithm. And this is more on the hardware side, GPS denied environment. Most of the time, the GPS is the guiding rule. GPS is helping the drones to find out their coordinates. But just imagine a situation, there is a GPS spoof. Suppose our drone swarm is working on the LOC or LAC. Right? Suppose they are working on the LAC for the surveillance drones. Surveillance drones are there, they are working on the LAC, China border, right? They are surveillance drones, no, not defense drones, surveillance drones. They are surveying only, right? Surveillance is going on. Now there is a GPS spoof from the side of China. They have said, you know the GPS can be for around 1 minute, anybody can stop the GPS signals, completely stop the GPS signals at particular area, around half kilometer, 500 by 500 kilometer, 500 by 500 meter area, they can stop the GPS. Just imagine they have done it during that surveillance. The swarm is flying here, during the same time they have done. Now they will be collapsed with each other, they will go in different directions, they may cross the LAC also. And then they may immediately, the enemy may have immediately region to fire, right? That your drones are coming in our side. So GPS denied environment is again a situation that if the GPS denied environment occurs during the flight, how to handle that situation? If no GPS signal is there, how to handle the situation? What should be done? So this should also be incorporated in advance in the algorithm. Okay, these are just different kind of scenarios. I have already. Okay, there are many different kind of application areas. Most of those application areas I have already told you during the examples. That security, survey, monitoring, surveillance. These are the areas where the drone swarm can be applied, and they can solve the problem more efficiently than the human beings. And disaster management is one of the most important area over which I also worked with Indian Air Force over this project, disaster management. HADR scenario means when there is a flood or fire broke or avalanche or these kind of situations are there, then how to identify the survivors and how to supply the immediate relief to those survivors, or how to find out those coordinates so that the help can be reached to that particular area. So during the fire rock, avalanche or the floods, in these kind of area, in those kind of situations, time is very important. And time is important. Swarm intelligence is giving you efficient solutions. Swarm intelligence is giving you the solution in less than 1 hour. I told you that 10 drones are solving the problem in less than 1 hour. Means when the swarm intelligence is there, the same number of drones can identify the survivors in minimum possible time. Right? So for disaster management is one of the most important application area of the drone swarm. Of course, search and rescue. Classification of UAVs is actually another point not related to the drone swarm, but just quickly I tell you that there are many type of drones available. So for example, this is the fixed wing drones. Usually the fixed wing drones are not recommended for the drone swarm because they fly at relatively higher speed, and in the higher speed the communication may be less, right? The fixed wing hybrid drones are actually recommended. Actually what happens for the fixed wing drones also, you need a some takeoff plane you require, or the landing plane you require. For the quadcopters or hexacopters, you don't require any particular location or any particular kind of plane. They can take off from any place. So these hybrid drones actually gives you the both the facilities. During the takeoff and land, they can do without any landing space, or and they can fly at a higher speed whenever required. And whenever required for the hovering purpose, they can do the hovering also. So the hybrid drones are relatively better solutions. Of course, nothing comes free, no free lunch. They have their own problems that during the transition from the fixed wing to the rotary, sometimes they crash. So still the robustness is to be achieved in this hybrid system. Single rotor, I think this toy, I think we all have seen this toy for our kids. So single rotor drones are okay for the short distances, not for the large distances. This hexacopter is, of course, this quadcopter is okay, but robustness is relatively less as compared to the hexacopter, because what happens in the quadcopter, if one or more arms are broken or the battery is failed, right, that particular arm battery is failed, then they will be crashed. Definitely they will be crashed. In case of the hexacopters, even if the one arm is broken or one battery is not working sufficiently, one arm's battery is not working as required, even in that case, they are so robust that they can land safely. Your machine is intact. Your machine is safe. You will not lose the machine. They will land at that particular place. The future. No need to say that the drone swarm future is very, very bright. I already told you that in next 10 years you may not see any job for the fighter pilots, because most of these jobs will be done by the drones or by the unmanned machines. Now, I don't know that in 10 years what new kind of drones or unmanned machines will come, unmanned vehicles will come. Another future is that there is a called UGV, you must have heard of it, unmanned ground vehicles and unmanned air vehicles, UGV and UAV. The future is very bright with the combination hybrid of the UGV and UAV also, that the UAVs are guiding and UGV are taking actions. The future is also bright in case of the transportation drone swarms. Transportation drone. So everybody heard about the drone taxis. and drone taxis will be very soon, they will be reality. They will be reality. I don't know when it will be reality in India, but that those will be reality. Those will be reality very soon. Drone taxis. In case of drone taxis, we must require the drone swarm, because suppose in a city many drone taxis are flying, then they should be, all the drone taxis should be interconnected. If not, then they may face problems in of the college, right? So the swarm intelligence, of course, is there. Drone swarm market is expected to have the highest growth in the year 2018 to 28, and that is around 37.49%. It is expected to increase with this rate. By 28, the drone swarm market in industry, it is going to increase by 37.49%. Actually, there are thousands of the swarm intelligence based algorithms available, but I tell you that 80% market of the swarm intelligence is covered by the two algorithms. I also proposed one algorithm in 2014, spider monkey optimization algorithm, but I tell you that 80% market of the swarm intelligence is taken over by the ant colony optimization algorithm and particle swarm optimization. These only two algorithms are so important, so efficient, so good that they covers the 80% market. Of course, other algorithms are also good. They are sometimes they are better than these algorithms, but they are relatively new. Industry is yet to be accept that algorithm. They are relatively, industry has first time adopted it. Now, I can adapt. I need to just do the simulation. Even if the simulation fails, nothing will happen with me. But with the industry, lot of investment is there. Hardware investment is there. So they not immediately they accept or adapt the new algorithms. They take time to adapt the new algorithms. But right now, these two algorithms are quite popular in the industry: ant colony optimization and particle swarm optimization. Those who do not know the swarm intelligence, I strongly recommend you start with the particle swarm optimization. You start with the ant colony optimization algorithm. They are relatively very easy algorithm. Very easy algorithm. A lot of lecture. My video lectures are also available on YouTube. You can Google them. So in the 30-40 minutes you can understand these algorithms. Those are not rocket science, but the applications are Myrick's applications are there. So this is my research. I think I should stop or to stop, right? So this is my very recently we did this research on the drone flocking optimization using NSGA2 and PCA. NSGA2 is the algorithm for handling multi-objectives, and the PCA is for handling the to reduce the number of objectives from 7 to 2. PCA, principal component analysis, we used, and this is not to be covered because it will again take much time, and this research is available online. Very recently it is published in Swarm Intelligence Journal. Simulation videos are available online. Links are available on the research paper. Links are available. Research paper is available. It is freely available also. You can refer this research paper. It is really good. And this is the first time when we use the PCA for the reduction of the objectives, number of objectives. Okay, thank you so much. So that's all from my side. Thank you so much. Have any question or to be discussed, or we can discuss? Or?
Even you can ask questions if you have listened properly.
Any question? If you have any question, just we can talk 1 or 2 minutes. Otherwise, I know we all are getting late for the lunch. Yes, please.
Of the drone network. So because the drone has usually a very common change in data. So if because cyber attacks has become very common, so how challenging is that for some drone attacks or data?
So fortunately, ma'am, we are very lucky that this cyber attacks, this drone swarm is safe. they are using, there is a very famous algorithm AES, you heard about, Advanced Encryption Standard. So AES 256, earlier they used to, they were using AES 128, but now it is inbuilt in the, it is inbuilt in the simulator, AES 256. Right, so AES 256 is being used for the inter-drone communication during in the network. So they, through AES, they can immediately identify the friend or foe. Who is the friend? Who is the enemy? Right. So even if there is a cyber attack in the network, they can easily handle. Why it is being used? AES 256 is being used because it's a private key cryptography. So private key cryptography is relatively fast. So we need any algorithm which is fast, which can be implemented for the real-time system. Right. Of course, we can think of some public key cryptography algorithm also, but that may slow down the system. So AES 256 is the most optimal solution right now, and it is inbuilt solution in the system, in the what is called. I'm just sorry. That's a flight controller. In the flight controller, it is an inbuilt system. You need not to configure it separately also. Yes. Can you speak slightly loud?
One of your PPTs, there is an equation x equals to x plus into x equals. So there is a neighborhood drones controlled by something. That's the explanation.
Okay, I got it. Actually, the question is, his voice was not so loud, so let me explain the question. He said about that T. How about that T in that update equation? Yeah, here it is. So this T, how this T is to be, so this T is not about the neighboring. This HG is the neighboring, best of the neighboring candidates. This T is the weight to them, that how much weight I am giving to them. Right now, this T is a probabilistic candidate, right? Probabilistic weight. So this is a random number. Now this random number may be 0 to 2, between 0 to 1, 0 to 1.5, or it may be minus also, means it may be in negative case also. Sometimes those drones have come very close to each other. In that case, they want to go away from each other. In that case, sometimes it may be negative also. But usually it is positive, and it all depends upon algorithm to algorithm. That it will be between 0 to 1, between 0 to 0.5, 0 to 1.5, 0 to 2, 0 to 10, 0 to 1000, whatever. Depends upon algorithm to algorithm. If you are using ACO, it may be different. If you are using ABC, if you are using PSO, SMO, GW, whatever the algorithm, the T differs algorithm to algorithm. So algorithm is giving you the idea about this T. So it is not to be done by you. The algorithm will tell you that what should be the G. Right? In the basic algorithm, suppose you are customizing ABC for the drones. Then in ABC, this T is a random number between -1 and +1. Just for example, I tell you, for ABC it is -1 to +1. So actually the algorithm is giving you, the basic algorithm is guiding you that it is between -1 and +1. Now it depends that during the customization for the drones, it may be slightly 1.2, -1.2 to +1.2 maybe, or 0.9 to -0.9 to +0.9. So you need to do it through simulation. Through simulation, which particular value is helping us, right? But it will give you some idea.
What is the significance there with respect?
What is the
significance of T with respect to the drone functions?
I'm not getting.
Significance of
T value. This T value is very important, most significant part actually. How much weight? I cannot give it 1. Remember, 1 means I'm completely believing on my neighbor. Even if this neighbor is going in wrong direction, then I may also go in the wrong direction, because his input is probabilistic and he is giving the information probabilistic, but I'm taking it deterministic. Means you said to me कि आप ना ये वाले टॉपिक पे लेक्चर दे दो, ठीक ही हो जाएगा शायद, लेकिन मैंने पकड़ लिया कि नहीं मैं तो यही दूंगा फिर आपको. You said शायद, but I decided it deterministically. Means the information is always probabilistic and therefore it is probabilistic value, some probabilistic value. So it is affecting too much. If it is too much value, large value, it means I'm giving too much weight to the other's information. If it is too less, then I'm giving less weight to this information, right? If I'm giving too much weight, there is my friend who said that, okay, you should not be a professor, you should be a businessman. My father says that, no, you should not be a businessman, you should be a professor, right? I said that, no, my friend is correct. I'm giving 100% weight to this. It means too much weight I have given to my friend's info, and I become the businessman. But
in some cases, constant T, right?
no, constant value. Constant value for the upper bound. I think you studied PSO, right? You know the PSO? So in that PSO, it is a constant value for the upper bound. That C1, C2 are the acceleration factors. That is 2, right? You know that. So in that 2 is a constant value for the upper bound. It means the random numbers are between 0 to 2. It is not a constant. It is the range. Constant is the upper bound. It is the range, constant range, that random number between 0 to 2, right? So this T is depend, like for example, PSO you are using, then it is 0 to 2. If you are using ABC, then it is -1 to 1, and others. Actually, if I would have given to you Nobel Prize for this question, really I would have given this. Actually, this is the one most important question, that why the customization of the basic swarm intelligence algorithm is required for the drones. Why not the original PSO is used directly for the drones? The reason is, let me tell you, question is very good, the answer is also very good. In the PSO, the superimposition is allowed. Superimposition is allowed means the ultimate objective of the PSO algorithm, when the distance between all the particles becomes 0, right? We want all the particles clustered at the optimal solution, right? But here it is not allowed. Here it is not allowed because the drones are some real entities. They are not the virtual entities. They are the real entities. If the distance between the two drones becomes 0, they will collide with each other, right? And the objective is also not to reach all the drones at the same optimal solution. There may be another kind of problem where you have so many survivors. The PSO used for the global optimization problem, a single optimal solution. Here the solutions are so many solutions, right? So many survivors are there. So simultaneously you need to find out so many survivors, and you want your solutions to reach there. Your solutions to reach at all the survivors, right? So you don't want to make the distance 0 between the drones. And the basic PSO, the ultimate objective is to make them 0. This is the basic difference, and therefore we need to customize PSO for the implementation to the drone swarm. जी सर.
So that means some will be smart, some will be less smart, some will be not smart. That means, so this is the approach in credibility. That is because of this smartness, intelligence, some will do what more, some will do what less. So that how we can solve the number of processes group to solve the problem.
Actually, sir, what happens, the necessary condition for the swarm intelligence is the homogeneity, I told you. So we cannot say that some solutions are intelligent, some solutions are not intelligent. What I understood from your question may be wrong, that you want to say that there may be few solutions which may not have more information as compared to others. So actually, initially, the basic definition of swarm intelligence, that all these solutions should be at equal level. Means all the solutions have same level of information about the optimal solution. Now, out of these informations, one may be better because all the solutions are initializing their positions randomly. Some are better, but eventually other members will also become better based on the collaborative behavior. The swarm intelligence, what you do, the collaborative behavior, you help me, I will help you, right? So even if one has the better information, the other will reach there. So ultimately all will become equally intelligent, right? So there is no case when we should consider that one has a better, and we never distinguish also among the solutions. We never distinguish also that one is better than the other. We distinguish always based on the fitness value.
All the users know in the same time.
Okay. I think you want to say that the operation time of the drones. So yes, every drone should work, or every particle should work simultaneously. All are working simultaneously, same time.
This is equivalent to the job of the bot. God is solving so many problems, complex problems of this politics, society, accident, health, conditions. So this is the very complex problems. So how they are taking the all the inputs and solving the certain problems. So you are giving some solutions more better.
Comparing with the God's activities, it's not possible, but
This can be applied in the politics to solve the politics, to get the political solutions. Like in job, many jobs are moved in politics. So similarly can be applied with non-swarm intelligence and reducing the number of politicians to get the better decisions.
सही है सर. आप भी आपका आइडिया है, देखते हैं. For politics, yes. Might be possible. So, should we wind up? Okay. Okay.
To reduce the computational time, they are using more number of drones.
No. Yes, at a certain level, you can increase the number of drones, but that is not means efficiency is not inversely proportional to the number of drones. You said it that number of drones increase, efficiency is proportional, is proportional to a certain level. Means if you want to search an area of suppose 10 by 10 kilometer area, then you assign 50 drones. 100 drones may increase the efficiency, but not 200. After 100, 200 may create a problem of communication. And the communication failure may be there. One or more drones are crashing and they are creating a disturbance to others also. Right? So this is not like in PSO. Right? There is a trust problem that is called grieving problem. Right? Very famous problem, grieving problem. Except the grieving problem, for all the problems, increase the number of particles, increase the accuracy. Right? So number of particles is proportional to the accuracy. In case of drones, it is not true. After a certain level, there is some kind of critical point. There is a CPM. During the CPM, there is a critical point that after this particular time, you cannot reduce the labor time. Right? So similarly, here the number of drones you can increase the efficiency, but after a certain time, you cannot increase the efficiency.
Number of drones, then don't you think it will increase the price cost?
Definitely. And the drones, these drones which I am talking about, the survivor drones, HADR drones and all, they are not cheap drones. They are not thousands. They are in lakhs, in crores. 5 crores rupees drone. And I saw live the 5 crore rupees drone is burning in front of me. There is a malfunction in the engine and it is burning live. So they are very, very costly drones. So 30 to making drone 30 to 50 is very costly. Dr. Ram Ratan is from the DRDO. He has a very good lab and the DRDO, and they are working on the drones. You are not. I know you are in SAG. You were in SAG. I know. But there is another lab that is working in drones, and they are providing very good solutions. They have a dedicated DRDO Delhi. They have a dedicated testing facility also, and I think world's one of the top testing facilities there for the drones. Simulators, great simulators are there. They have very, very good simulators also. Sorry. नहीं ओवर इंटेलिजेंस नहीं, ओवर नंबर ऑफ पार्ट्स. मतलब जो काम यार एक कमरे में झाड़ू लगाना है, जो काम 10 लोग कर सकते हैं, अभी 50 लोगों को उस कमरे में तो झाड़ू नहीं लगेगी, वो गंदा ही होगा उल्टा. हाँ, ओके, थैंक यू सो मच. थैंक यू सो मच.
Thank you, sir. Thank you so much, sir. Yeah. So on behalf of SoCTA 2022, I thank Professor J.C. Bansal. I request Professor Tarun Kumar Sharma. It's not, I don't know what happened. चल रहा है. Yeah. Thank you, sir. And I request Professor Tarun Kumar Sharma, Dr. O.P. sir, Sanjay sir to please felicitate our keynote speaker, Professor J.C. Bansal. Thank you, sir.
सर एक फोटो इसके लिए, इस वाले कैमरे के लिए. हाँ जी, थैंक यू सर.
We have Dr. Anindra Bose, sir. We could not have his because of his sore throat, but sir, as we promised, we'll have it online. I request you on stage, sir.
In advance.
In advance, the felicitation in advance.
And you were not giving keynote.
Thank you, sir.
Done, sir. Done. Thank you.
So we now have lunch in the guest house. So I request everyone to join for lunch, all the participants. And from there we'll have a cab to UIT where we'll have the paper presentations immediate after lunch.